rule for this one is inside the title, okay? Multiply a logarithm by its exponent. I alluded to that in the logarithm change of base proof. Whenever you have an exponent inside of a logarithm, what you can do is take that exponent and move it out front. I'm going to give you an example, okay? Let's say you had, didn't mean to do that. Let's say you had a log base 2 of 4 cubed, okay? So does everybody understand that the 3 is an exponent to the 4? All this rule says is you can take that, whatever that exponent is, and move it out to the front of the log. Okay?
So it'd be 3 log?
So it would be 3 times log base 2 of 4. And it's easier that way. Instead of cubing 4, you can just find the log and whatever that is, end up multiplying it by 3. That's the gist of this. Okay, again, you don't have to write the proof out, but I will explain it. So let's say in general, we have log base a of x to the n. Okay? Now, let's assume first of all that y equals log base a of x without the exponent. If we convert that to an exponential, it would be a to the y equals x. Okay? Now I'm going to just flip them, put a to the y on the right, x to the left. Okay? And then the next thing I'm going to do is take log base a of both sides. Okay? So we have log base a of x on the left and log base a of a to the y on the right. The next thing I'm going to do is raise both sides to the power of n. Now what happens on the right is, because that's base a, it's just going to become yn. A power to a power equals multiplying. So on the right we're going to have yn. Okay? Then I'm going to flip y and n, become ny. And then the last step of the proof is, we originally said that y was equal to log base a of x. So I'm going to replace that y with log base a of x. And now we have n log base a of x. So what I've just shown is, if you take this exponent and move it to the front, that's what you can do. It just becomes the coefficient of the log and the exponent goes away. So all of that to be said, let's show how this would work in action and why it's important. So first of all, log base 2 of 2 to the 100th power. 2 to the 100th power is a huge number, okay? It's really, really big. But imagine if we just took the 100 and moved it to the front and then evaluated that, okay? So what is log base 2 of 2? It's just 1, right? So instead of doing 2 to the 100, just evaluate the simpler log, it's 1, and then take the original exponent and multiply that. It's just 100. So that's why it's nifty, is because you don't have to figure out some ridiculous exponent. You can just make the exponent the coefficient. All right, let's... Oh, you want to write that down? It wasn't really an example. It was just illustrating why it's useful. But you can write it down if you want. I'm not going to... Going back to why this is important. Instead... So let's read this. Log base 7 of 49 cubed. Instead of cubing 49, which again is a really big number, because you can multiply a logarithm by its exponent, you can just take the 3, move it out front. Okay? And then evaluate the log. Now log base 7 of 49 means 7 to what power equals 49? It's 2. And so it's a lot easier to move it out.
2 is 6.
Exactly. That's all you have to do.
So then x equals 6, right?
So what did I tell you guys about a radical? How do you convert that to an exponent? Square root.
You put the exponent back, so it'd be 3 fifths. I think 25 3/5.
Whoa.
Just the square root. Don't worry about what's inside. Becomes 1/2 power. Okay? If you take the square root of something, it becomes to the 1/2 power. So this becomes log base 5 of 125 cubed to the 1/2. We'll talk about where to go from there. Actually, I'll go ahead and ask you, what do you do when you have a power to a power?
Multiply the powers together.
Yes. So we're going to do 3 times 1/2 to get a new power. Okay, a power to a power means you multiply the powers. So 1/2 times 3 is 3/2. But instead of having to evaluate 125 to the 3/2, this is an exponent, right? So you can move it to the front. So it's going to become 3/2 times log base 5 of 125. Who can tell me what log base 5 of 125 is?
3.
3, why?
Because 5 times 5 is 25. 25 times the third 5 again.
Because 5 to the third power is 125. So this is just going to become 3. I'll give you a second to copy this. Okay, so log base 5 of 25 is 3. So then you just take that exponent 3/2 and multiply by 3. Why do the 3's not cancel here?
Because in order for them to cancel, that
3 would have to be on the bottom. Yep, so it becomes 9/2. Over one more example. This one's easy. Log base 100 of 1,000. So imagine doing 100 to the 1,000th power. That's really, really big. This makes it a lot easier. Move the 1,000 to the front. Well, log of 100, when there's no base listed, it's 10, right? So 10 to what power gives you 100? 2, right? And then just take the original exponent. 1,000 times 2 is 2,000.
2,000.